Okay, so welcome everyone. Welcome to the Sirius by Example talk. So I'm Pierre-Charles from Obeo, Sirius co-lead.
I'm Stéphane Bonnet from Thales.
And I'm Alex Lagarde. I work as a Sirius committer from Obeo too.
So today we're going to present you the Sirius project and how it can help you to very quickly create your own graphical modelers. But first, what is Sirius? Well, in a nutshell, Sirius is a system which allows you to really quickly create your own multi-view graphical workbenches. You can create modelers based on graphical shapes, trees, and tables very quickly. And it works with any EMF-compatible data model. And also, it's very quick to use. We'll show you in the demos that you can get a working solution in just a few minutes and iterate very quickly. Sirius is based on and leverages many of the Eclipse modeling technologies, like EMF and GMF runtime, for example. But you do not need to be an expert in these technologies to use it and to get a working modeler. Indeed, part of the mission of Sirius is to bring all the cool stuff which exists in the Eclipse modeling technologies to the masses and package them in an easy-to-use way. And finally, Sirius is both a new Eclipse project. We just committed the first commits in last September, and also a proven and mature technology. It's already been deployed and developed by Thales and Obeo for more than 4 years now. So what are the benefits for you if you adopt Sirius? Well, if you're a developer, it greatly reduces the cost and complexity of creating your own modelers. In particular, you don't need to become an expert in GMF to get a working graphical modeler. Sirius also enables a very dynamic and iterative way to develop modelers with no code generation. You'll see on the demo that you can make, when you change the definition of your modeler in the configuration file, you can get instant feedback on your modeler and iterate really quickly. We believe this particular feature is really game-changing compared to other technologies. For end users and customers, what this means is that instead of adapting your way of working to a few existing and standardized modeling languages and associated tools, it becomes possible to create your own modelers adapted to your specific way of working. And it's so easy that you can easily create many different modelers for different kinds of users and different kinds of tasks. Finally, Sirius provides an improved experience compared to raw GMF. Over the years, we have added many features and extensions to the basic technologies based on our users' feedback from, in particular, from Thales operational projects. So how does it work? It's made of two main parts corresponding to the two kinds of users. Shown on the left here is first the specification environment. It's what used by the specifier, the developer of the modeler, to define how the modelers will work and how they will look. And the end users never see this part, actually. They don't need to have it installed. On the right, you see the runtime environment, which is installed on the user's machine. And its role is to interpret the configuration file defined by the specifier and provide a concrete working modeler. So once the end user has installed the runtime environment, to get a new modeler, it simply has to install the completely standard Eclipse plugins. So the specification environment, it's the tooling you will use if you define a new Sirius modeler. So you have an example here shown on the right. It presents itself as a tree-based configuration editor, where you can define diagrams, trees, and table-based modelers. For which modeler you define, you need to specify what you want to have appear, what kind of, which data elements you want to show on your representation, how you want them to look, so styling information, and how you want them to behave. That is, the tools you want to appear on the palette, for example, and how the elements will react to user interactions like drag and drop, edge reconnections, etc. To use this environment, you need very little technical knowledge. You must, of course, understand the structure of your business data, but hopefully that's not a problem. It's recommended also to know some OCL, to write a navigation expression inside your model, although that's not a hard requirement. But importantly, you don't need to understand the details of EMF, GMF, and other technologies under the hood. The recommended way to define a Sirius modeler is to do it interactively, as we'll show you in the demo. So you get a sample data model, and you open an empty modeler on it, and iteratively you change the configuration and see directly with instant feedback the result of all your change until you iterate until you're OK. So the configuration language you can use inside the specification environment is already pretty powerful with many features. When you need it, you can also call Java code at almost any point to call complex algorithms or existing library code, for example. And you can also call extension point from Sirius or from EMF and GMF if you need. So I said you don't need to understand EMF and GMF, but they're still there under the hood. And if you need all their specific power, you can still access it. Now the runtime. It's a part which is installed on the end user's system, and this role is to execute the specification you specified in the environment before. It does this by interpreting the configuration file, and there is no code generation or any other intermediate step in between. It's really purely dynamic. Sorry. With Sirius, it's very easy to create different modelers to see the same data model through different point of views, so that different users will not see the same level of details or will not have the same tools available to them. Sirius leverages the notion of viewpoint for this, so specifiers can organize the different representations they specify into different viewpoints. And end users can choose to enable or disable these viewpoints to customize their experience depending on their role or on their current task. Finally, the runtime also provides a simplified workflow in the workspace with the notion of a modeling project, which handles all the issues related to life cycle of the resources and operations to manage the viewpoints and the different representations. So now I let Stefan talk a little bit about the history of the project.
Yeah, so a bit of history, how Sirius started. We at Thales had a few needs regarding the development of system engineering modeling workbench. And to do that, the natural way would have been to use UML, but we have had previous experiences with UML, like seeing a poor adoption by our system engineers. Usually UML is well accepted by software engineers, but less by system engineers. We were constrained by UML concepts, and we were constrained with the representations we could have in existing UML diagrams, like layers and filters, things that we will see in Sirius. In the same time, we had needs for several modeling workbench. So instead of just starting modeling our own DSL with GMF, we started to work with Obeo and invested on this technology. So we invested on building Sirius, which provides a generic infrastructure for model management and the representations, and that let us focus on our added value, like our own business. And of course, everything we've put in Sirius is available now for all our other modeling workbenches. So this started in 2007, where we had our first prototype to validate the main concepts. And then it entered a phase of heavy development with quite a lot of people involved in that. So in 2008, we had the specification and development of Sirius foundations. And in 2008, we were able to deliver our first modeling workbench. So it's similar to UML and SysML, and to deploy it within Thales. based on the first versions of Sirius. In 2009, it has been integrated in Obeo Designer, which is a commercial product. And from 2009 until now, we've been just working on making it more robust and more mature. So who already uses Sirius? So I'm talking here for Thales. On the following slide, you will see who uses Sirius outside Thales. We use Sirius in all our domains. So that goes from avionics systems to transportation, communication and security, ground, air, radars, space, air traffic control, and in different countries. So mainly France, but also Canada, Germany, the Netherlands, Australia, Italy, and since 3 weeks ago, Singapore. We have one flagship modeling workbench, the one we have invested the most on, but we also have 4 or 5 others. So let's say we have 5 modeling workbenches based on Sirius. We have about more than 60 operational projects. We have about 150 engineers that are trained each year to use our system modeling workbench, so based on Sirius. About 300 users and everyday users. So that means these are engineers. When they get to work in the morning, they just launch our modeling tool and they switch it off at the end of the day. We have, of course, more users than that, but these ones are really the ones who spend their day working with Sirius, without knowing that it's Sirius, of course. We have about more than 500 diagrams in some of our biggest models, and a bit more than, well, almost 1.5 million elements in our biggest models.
Okay, so in addition to the Thales use, we already have a lot of users which are already using Sirius. So first of all, it's been 4 years now that we embed Sirius in 2 of Obeo proprietary products, which are Obeo Designer and Obeo Smarty, a tool dedicated to managing enterprise architectures. And the fact that we embed Sirius in those proprietary products makes that we have a lot of use cases with a lot of customers. So from designing space components to managing insurance company offers, for example. And in addition to these commercial users, we also have a lot of open source users. We have defined some open source modelers which are available on the Eclipse marketplace and on GitHub. So for instance, we have UML Designer, which is the most downloaded one, and a bunch of others. And for the most popular modelers, we are more than 1,000 installs a month. And of course, you are now able to use Sirius. There is an integration build of Sirius 0.9, which is available for a few weeks now, so you can download it. And we plan to make Sirius 1.0, the first official release of Sirius, aligned with Eclipse Luna, so it will be available in June. But enough with the chit-chat, let's see Sirius in action. So first, a few words about the demonstration of our environment. We are using an Eclipse Kepler SR1 with Sirius 0.9 installed, the latest integration build. And all that we are going to show is available on GitHub if you want to see the example. So for this demonstration, I will play the role of the customer who has no technical knowledge and who will express the needs of his modelers. And Pierre will play the role of the specifier, which will implement the modelers using Sirius. So Pierre, this is what I want. I'm a project manager, and what I want is some kind of roadmap diagram that allows me to see all the tasks that are defined on a project and be able to assign people to it.
Okay. Do you hear me with this mic? Yeah. Okay. So let's see how we can do this. So first, let me introduce you the data model we've been working with. We have already defined it. It's not part of Sirius. So this is an EMF meta model. If you're not familiar with meta models, don't worry, just think of it as a data schema for the business data. So we have the task repository at the top, which contains projects and persons. And projects can have leaders, and projects are made of specific versions, each with a release date. And tasks are contained inside versions and can be assigned to people. So I've already generated all the code needed for this and installed it. And to create a modeler with this on this data, the first thing I need to do is to create what's called a viewpoint specification project. I call it tasks.design here. So it's a completely standard Eclipse plugin project, except that it contains a configuration file here for Sirius modelers. So I gave a name to the top-level element. And inside of this, I can create different things, but most importantly, a viewpoint. Here, because Alex is a project manager, in this case, I create a project management viewpoint, which will contain all the representations on this data targeted for this kind of users. Inside of this, I can create different kinds of representations. By default, Sirius supports three representations, 2 kinds of tables, plane diagrams and sequence diagrams. Here we use a plane diagram. I hide this. And I call it a roadmap. I just need to specify here in the green text area what kind of data element the diagram will be working on. So it will be on a project. We'll have 1 roadmap per project. And to finish, I need to create a default layer. Layers are used to organize the different elements on a diagram. So once I've done this, I've already defined the working modeler, although it's empty. And I can switch to the role of the end user to test it. So assuming this will be installed in the end user's system, to use it, the user has to create what's called a modeling project. I call it tasks.demo. It's a normal project but with a specific nature, and it already contains this file here, which will be used by Sirius to store all the representation-specific data outside of the business data, so all the diagram shapes and locations. So I've prepared here a sample data model. I just copy it here. Sirius detects it and loads it as a model, so I can dig into its structure here. And I see I've already defined a few projects and persons. And to actually use this modeler, I need on the demo project here to enable the viewpoint which defines it, like this. Enable project management. And once I've done this, I go on Sirius and I can create a roadmap. Sirius roadmap. So as we expected, we get an empty diagram. I put it here on the right, on the right, like this. And I keep this layout for the rest of the demo. So remember that what you see on the right is what the end user will see once the modeler is fully developed and deployed. But when you are developing as a specifier, you can get both at the same time and iterate quickly. So Alex wanted to see tasks on his diagram. So to make things appear on the diagram, I need to create what's called a mapping. Here, a node mapping will do. I call it a task. I need to tell Sirius what kind of data element this will represent. So in this case, a task element. And here I need to enter an expression which, from a given project, how do I find the tasks you want to see on the diagram? So you can use many languages. Here I use a really generic OCL expression to get all the tasks contained inside the project. I also need to define the style. So we have many different kinds of styles. I'll use one of the default ones here. Many configuration parameters. I will not show each of them. So sorry, I will hide the icon and tweak the position of the label and change the color to a nice dark blue and blue. So when I save, I see my task appearing on the diagram. So I just adjust their size here. So for each task Sirius found inside the system, it created a blue shape on the diagram. Next, Alex also wanted to see people, so I need another node mapping, call it person, for different kind of data elements. And here I leave the expression empty to tell Sirius, show me all the people you can find inside the model. And for the style, this time I will use an image from the workspace. It's in the demo project, so I just need to give the path here. And when I save I get an error. Sorry about that. I need to restart. Sorry, no live demo works here. Sirius. Sorry about that. This never happened, of course. So I need to reopen the diagram. I need to recreate it, sorry. Here. So now I have my persons on the diagram. Sorry, I need to readjust a little bit the layout. Sorry. Okay.
Anyway, who is invalid feature as name? Don't know that guy.
Yes, so this was because by default here, if I go to the definition of this element, by default the Sirius expects the presence of a feature called name to show the label of the feature. There is no name for a person. It's defined using a first and last name. So I need a computation expression here to get a nicer label. So I use first name plus last name. And now I get a nicer label for people on my project. So the final thing I need to do to get what Alex wanted is a relationship between tasks and the person they're assigned to. So to do this, I need a new kind of element. It's called a relation-based edge. It will represent an assignment. I need to tell from what kind of element it goes from. Here, a person, and it goes to a task. And here I need an expression, given a person, how do I find all the tasks to which I need to show a relationship. So here I've already the explicit relationship in my diagram. It could be a more complex expression here. For the style of the relationship, we'll keep the default, except maybe use a dash, but you can change the decorators, the colors, etc. And when I save, I see that Stefan is assigned to the release review. If I select an element here and change the model underneath, for example, I assign this task to myself, the diagram is automatically updated. This is not specific to, I did not write any code for this, it's just that the model is fully synchronized by default with the diagram, sorry, is fully synchronized by default with the underlying model, so each change on the model is reflected also in the diagram. So this looks a lot like what Alex drew on his blackboard.
Yeah,
whiteboard, sorry.
This is what I drew, but by looking at it, I'm missing an information. I need to know in which version is defined each task. Would you be able to regroup each task according to its version?
Yes, so to do this, we need another kind of element on the diagram, which can contain other elements. So we have this here with a different kind of mapping called container mapping for versions this time. It's called project version in the system. And here, from a project, I show one such version for each version of the project. For the style, I'll use one of the predefined one and tweak a little bit the label, for example. Use rounded corners and change the color to light green. So when I save, I see my two versions defined in the model appearing here.
Yeah, but I want my task to be inside those versions.
Yes, we are not finished. We have defined both tasks and versions at the top level of the diagram, but of course tasks are inside versions, so I just need to change it here, and the tasks are moved. Actually, it's new elements which have been defined, so I need to adjust their size now. Here we are.
Okay, so that's cool, but how can I edit this model? For instance, how can I add a new task, for instance, inside my versions?
Yes, so for now it's a pure visualization. We can also create tools to edit the model. So to do this, we need to define a tool section here. And inside this, we can create many kinds of tools to customize almost all behaviors of our modelers. So you can create new elements, define the behavior, customize the behavior, drag and drop, element copy-paste, element deletion, edge reconnection, etc. Here we need the node creation tool to create a new task. It will create elements of this type on the diagram. And now we need to define the behavior because it's completely open, so I need to specify even if in this case it's obvious. So I have access to a small imperative language here with many operations relevant to model modification on models. So here I need to create an instance inside the task reference of a task. And once it's created, I'll set its name to new task. When I save, it appears in the palette and I can start to use it. So it's disabled everywhere it doesn't make sense. I can't make a task inside a task, inside a person, but I can inside a version. So I create one here. For example, we need an IP review for the release. Yeah.
Okay, that's great, but as a project manager, what interests me is to see all the tasks that are not assigned to anyone yet. So do you have a way to make them pop up?
Yes, there are several ways in Sirius, but here we use a conditional style, so I can go back here to the definition of the task element. And as you see, we define a single style, which is always a blue square for all tasks. We can also create a conditional style, which will only be enabled for tasks which match some criterion. Here we use an OCL expression to match tasks which have no assignee. So this is the OCL way to test this, and I just copy this existing style and change the colors.
In red. Red will be great.
Yeah, in red. So when I save, all the tasks which match, and only the tasks which match this particular style are changed. So now I can see which ones I have to assign to people, for example to Alex, this for myself, and it's updated according to the structure of the model directly.
Okay, that's almost perfect, but I don't always have to see the person and their assignment. Sometimes I just want to see the task. Do you have a mechanism that will allow me to show them when I want to?
Yes, so there are several mechanisms in Sirius to allow end users to control what they can see on the diagram, filters, layers, etc. Here we will create an additional layer which will be optional. So here, an additional layer to contain all the person-related stuff. And I'll move person and assignment inside this new layer. When I save, all the corresponding elements disappear on the diagram because the layer is disabled by default. Here, the user can choose to enable it again. So the layout is lost because in this case, I've updated the definition, so it's new elements. But when the user disables or re-enables the layer, it's kept. So the user, depending on what he wants to do, can control what he sees.
Okay, so I think you're done. For me, it's the diagram I wanted. But now I'm thinking that the other developers in my team may not want to see all the tasks. They will want just to have a to-do list showing all the tasks they are assigned to.
Okay. So instead of a diagram, I propose to you to create a table for this. So I go a little bit quicker here with this detail. We'll create a new viewpoint for developers instead of project managers. And instead of a diagram, I create an edition table called to-do. It will work for each person. And here, the principles are the same, but instead of nodes and elements and edges, we specify lines and columns. So we'll create one line per task. So for one person, we'll get one task for one line for each task is involved in, and we'll get the name of the task here. I must create a column, for example, on the remaining time, like this. Like this. So now that I've done this, and to use this new table, I must enable the corresponding viewpoint here. And on myself, I can create a to-do list for me. A table appears, and I see what task I'm assigned to. I can create one for Alex. And I see that Alex has only one task assigned to him, so that's not fair. Sorry. So I get one of these, which is assigned to nobody, assign it to Alex, and as soon as the model changes, the table is updated too, because it's the same model underneath, and all representations are synchronized at the same time.
Okay, great. And can you deliver it to me tonight?
Yes, so once I've done this, if I wanted to ship it to a user, I just need to package the corresponding plugin here as a normal Eclipse plugin, and the user can install it. So here is what Alex wanted initially, and here is what he got in 15 minutes, I think. And now Stefan will show you what you can do.
Yeah, we're going to be quick because we are running late. No, it's, how can I see it? So it's a screencast that will run for 1 minute and something like that. So it's the Thales System Engineering Workbench, and I'm just illustrating here some of the capabilities of the tool. So for example, we are seeing here filters on diagrams. So we are able to hide dynamically all kinds of elements according to the focus we want to have on or be working on, and that helps us manage complexity. Sirius is also capable of helping specifying sequence diagrams with advanced previews and guards mechanism. We can see where we can drop the messages and so on. You have seen in the demo already some of the conditional styles. On this one, I'm just illustrating how we can, we have decorators indicating how we can zoom in the diagrams to navigate in diagrams or to highlight elements in diagrams. And we also have drag and drops with preview to where the thing will be dragged or dropped, and reconnect of edges. So we have a lot of small functionality like this one that is available and that we don't have time to demo in 35 minutes. We also have something very nice on the layout. We are able to pin some elements and just say, okay, the layout will apply to everything but these elements. And we also have something which is really, really useful. It's a copy-paste of layouts between diagrams, because having a nice layout is usually complicated, and when you can reuse it, you do. So as a conclusion, there are 3 things to remember about Sirius. It is a full-featured environment to create custom modelers. It is easy to use, so you have seen that in a few minutes, like 20 minutes or something like that, we have built a small modeler, which was quite nice. So it's fast, it's iterative, you don't need to recompile anything, and you see your changes in live. It is mature. Even though we saw a bug, you have to know that we are running into a heavy phase of refactoring to get ready for the 0.9 version. But the version that is deployed operationally is really, really mature. So it's both inside Thales and elsewhere via Obeo Designer. And it is an official Eclipse project with about 8 full-time committers, and 0.9 is coming soon. So that's for the roadmap. So the project submission was in March, and we are now working on the 0.9 version, which will come sometime in November, with version 1.0 targeted for Luna. And that's it for us. So if we have time for questions. Well, I'm not going to talk for Obeo, but from Thales' point of view, having Sirius in open source is a guarantee of having it used by a lot of persons and having. So we have invested a lot on that, and by making it open source, we're just trying to ensure that it will be used and it will stay in time. So it's. Yeah, it's exactly the same. Yeah. There's one feature that we have that is not going to be open source. It's a live modeling collaboration based on CDO. So this one is something we have. We are able to Sirius and our tool are able to work in live based on CDO, but that's not part of what we give in the open source. But the foundation, it's exactly the same. Any other question?
Oh, yes, yes. Yes, of course. Yeah, the question was about do we support undo redo, and yes, we do.
And this is something which is quite reliable because our users don't stop doing undos. No, that's when we started with Sirius and our system and the Thales modeling tool. The first months were difficult because the deletion of elements, the undos, they were not really stable, and they caused a lot of crashes. And when we have fixed these problems, then it became much more mature. So it was an indicator that we improved. Yeah.
So the question is about the expressions we show on the demo. It's not for constraint, it's for navigation inside the model to tell Sirius which elements to show, for example. And the infrastructure supports, it's an extension point, so you can customize it. By default, we support OCL, Axeleo actually. We support a few shortcuts for very basic access to features. And you can call custom Java code very easily with it also. No more questions? Well, thank you.